Although the Sun appears stable, its surface is in constant motion. Sunspots, which are cooler, darker regions, appear in cycles of about 11 years. Despite its power, the Sun is not an especially large star. It is a medium-sized star, brighter than about 85% of stars in our galaxy. The solar energy reaching Earth in just 1 hour is enough to meet global energy consumption for over a year. The Sun is composed mainly of hydrogen, 74%, and helium, 24%, with traces of oxygen, carbon, neon, and iron. The Sun rotates on its axis, but not as a solid body. At the equator, it completes one rotation in about 25 days, while at the poles, it takes about 35 days. The Sun is about 26,000 light-years from the center of the Milky Way and completes one orbit of the galaxy every 225 million years. Solar flares and coronal mass ejections can release more energy than thousands of nuclear bombs at once. In about 5 billion years, the Sun will run out of hydrogen, expand into a red giant, engulf Mercury and Venus, and possibly Earth. In many ancient cultures, the Sun was worshipped as a supreme deity. The Egyptians honored Ra, the Aztecs worshipped Tonatiuh, and the Incas revered Inti. In Hinduism, the god Surya represents the Sun, riding a chariot pulled by 7 horses. He is seen as a giver of life, health, and knowledge. The ancient Greeks believed the god Helios drove the Sun across the sky each day in a golden chariot pulled by fiery horses. Jesus of Nazareth is symbolically associated with the rising sun in early Christian hymns. In texts like the Benedictus, he is called the rising sun from on high. In medieval alchemy, the sun symbolized gold and the masculine principle. It was one of the 7 sacred metals and represented spiritual perfection, enlightenment, and the soul of the universe. Essential elements in our bodies like hydrogen, carbon, oxygen, and nitrogen are forged inside stars like the Sun through nuclear fusion. In the Sun's core, hydrogen atoms fuse into helium, releasing energy. Auroras occur when particles from the solar wind interact with Earth's magnetosphere. These particles excite atoms in the upper atmosphere, producing dancing lights in green, red, and purple near the poles. The Sun's magnetic field is incredibly complex and constantly changing. It drives solar flares, sunspot cycles, and the structure of the heliosphere, the bubble of solar influence that surrounds the entire solar system. The Sun loses about 4 million tons of mass every second by converting matter into energy. However, this is such a small fraction of its total mass that it will only lose about 0.1% during its entire main sequence lifetime. The Sun is not completely silent. Its surface vibrates with pressure waves, studied in a field called helioseismology. These vibrations provide insight into the Sun's internal structure. Photosynthesis, which sustains nearly all life on Earth, depends on sunlight. Without solar energy, carbon and oxygen-based life as we know it would not exist. Plants, algae, and cyanobacteria convert light into chemical energy. The heliocentric theory proposed by Copernicus placed the Sun at the center of the solar system, challenging Ptolemy's geocentric model. In 2021, NASA launched the Parker Solar Probe, the closest spacecraft to ever approach the Sun. It endures extreme temperatures to study the corona and understand why it is much hotter than the solar surface. The Sun is a G2V spectral type star on the main sequence and accounts for more than 99.8% of the total mass of the solar system. The sunlight we see takes approximately 8 minutes and 20 seconds to reach Earth. In its core, the Sun fuses 600 million tons of hydrogen into helium every second. The Sun has well-defined layers: core, radiative zone, convective zone, photosphere, and corona.